Hi students, good evening to everybody. So I started about the health and diseases. Last class we have started some of the bacterial, viral, protozoan and fungal diseases and their causes, how far they are actually being transmitted from one individual to another. And how far we have the ability to resist all these microorganisms. And for that we have the resistant power in our body, and that resistant power what we have against the disorders or against the diseases or against the disease causing organisms is called as immunity, what we started at the beginning. And in this class, let's see something about the different types of immunity. So normally, based on the nature, how far it is normally staying there in our body accordingly, and also how it is developed either along with birth or after birth. So generally, the immunity has been classified into two different types. One is present right from birth, a natural one. Another one is acquired only after recovery from the disease, that is after birth. So based on this concept, we have two different types of immunity. One, the natural or innate or inborn immunity, also called as non-specific immunity. Natural, innate, inborn or non-specific. The one which is present right from birth, it has not been acquired after birth. It is always present along with us since from birth. Another one which is acquired only after birth, that is called acquired or specific immunity. It is also called adaptive immunity. So why is it called natural right from birth? It has not been initiated by anybody. It is always there along with us. So why is it called as non-specific? If anybody enters into our body in the form of foreign molecules, they can be indiscriminately attacked by this system. They are not specific only to a particular microorganism or only to a particular molecule, namely the foreign molecule. They will fight against anybody. But in the case of acquired or specific immunity, why is it called specific? So this immunity attacks only a particular microorganism. For example, if there is one immunity attacking tuberculosis, it will not attack what we have, for example, the smallpox virus. It is always specific. It can recognize only a specific microorganism and eliminate it. But in the case of natural, it cannot recognize specific microorganisms. Whatever organism or whatever foreign molecule, any products that enter into our body, we indiscriminately eliminate from the body, and that is by the natural mechanism. Once again in that flow chart you can see the acquired immunity again classified into active and passive. You will see one by one, active and passive. So it is of longer duration, passive is of short duration. And then the active immunity, in both the cases we have some can be induced artificially, some can be developed naturally, and likewise in the case of passive also some can be normally formed naturally and some can be by means of artificial induction. So these are all the different types of immunity that is given in the flow chart. Let's see in detail about each one. Let us start with the first one. Natural, it is also called as innate because it is present right from birth, hence innate immunity. Natural as it is not being stimulated by any environmental agents, anybody from outside, it is called natural. It is non-specific, I mentioned already, it can attack anybody that enters into the body without any distinction. So it is also called as native immunity because it belongs to the body, already present in the body. So it is an inborn resistance to disease right from birth. That is why it is called innate. So I mentioned earlier it is present right from birth. So it is called as non-specific, I mentioned earlier, because it can attack anybody without any specificity. Anybody which is considered as actually a foreign agent or a foreign molecule can be attacked by this immunity without any specific, just actually, or without any specificity we can say. And normally it does not require the entire microorganisms to be stimulated. As I mentioned, it does not actually depend on real contact. So in the case of active immunity or just for example the acquired immunity, it can be stimulated only by the environmental agents, namely in the form of microorganisms or foreign molecules. But in this case, it is not necessary to have a prior contact with the microorganisms for the development of such immunity. So, it is non-specific, doesn't require the prior contact of any microorganisms for the stimulation of this immunity. So, normally, this type of immunity is called as the first line of defense. It is coming under the first line of defense, the innate immunity. So, what is the meaning of first line of defense? As in the case of, you know, that one army, we have first line soldiers, second line soldiers, the third line soldiers, like that. In our body also we have three different lines of defense. The first line of defense constituted by such immunity. For example, skin or any mucus layer, the hydrochloric secretions in the stomach, the fever response. So these are all coming under the first line of defense. For example, the skin acts as a barrier preventing the entry of microorganisms. If it fails to prevent the entry, then the second line of defense is operating in the body, namely the soldiers of the body, the WBCs. Even the WBCs are actually destroyed, unable to fight against the microorganisms, then we have the third line of defense, namely the antibodies. So likewise, we have three lines of defense in the body. One, just actually the first line of defense, then the second line of defense offered by the WBCs, the third line of defense offered by the antibodies produced by the lymphocytes. So, these are all the different lines of defense. Now, actually the innate immunity is coming under the first line of defense. Now, this one includes a number of barriers. The barriers which prevent the entry of microorganisms. That's what they call as the barriers. So, altogether there are four barriers as per our syllabus. Number one, physical barriers. Physical barriers. So these are all the barriers preventing the entry of microorganisms. For example, the skin, the best example for a physical barrier. Then the mucous membrane, a slimy layer present or found lining the wall of the intestine or simply the gastrointestinal tract, the respiratory tract, the urinogenital tract. So these two are coming under mainly the physical barriers, even the hands lining, for example the nose or the ciliated epithelium lining the trachea, all are coming under the physical barriers, preventing the entry of microorganisms. The best example is skin and mucous membrane. Then the second one, physiological barriers. There are certain secretions of the body. They are also helpful in preventing or destroying the entered microorganisms. For example, you have developed the fever response, or we have hydrochloric acid in the stomach which kills the microorganisms, or we have some substance found in the saliva, tears, etc. Lysozyme. So this is a substance found in the saliva, in the tears, and they also actually killing the bacteria by digesting the cell wall. So, these are some of the secretions of the body. For example, lysozyme, hydrochloric acid of the stomach. Then we have something released as a result of entry of virus, simply called as antiviral protein. It's an example of interferons. So, it is an antiviral protein produced by the cells once they are attacked, particularly the WBCs. They release the materials. So the physiological barriers mainly include the hydrochloric acid, and also we have, for example, the lysozyme present in the saliva, tears, etc., and something, for example, interferons. These are all coming under the physiological barriers, destroying the microorganisms, the invaders that enter into the body. Then cellular barriers. I mentioned the second line of defense also. The cellular barriers include the various types of WBCs. We have, for example, white blood corpuscles like neutrophils and macrophages. And these cells are having the ability of engulfing the microorganisms. Hence, they are called phagocytes. These are all called phagocytes. So, because they perform the function of phagocytosis. What is phagocytosis? Swallowing or cell eating. cell eating process is called phagocytosis. As these cells are engulfing the microorganisms and the products that enter into the body, they act as phagocytes during the phenomenon or process of phagocytosis. Particularly, neutrophils and macrophages dissolve certain WBCs concerned with phagocytic function. So, cellular barriers, we have the WBCs. Then cytokine barriers. These are all actually intercellular messenger molecules. Some messenger molecules are released. For example, histamine, serotonin, prostaglandins. So some other actually chemical alarm signals are bradykinin. These are all intercellular messenger molecules, interleukin 1, 2, etc. So there are certain chemicals, they have the ability of actually transferring the messages from one cell to another cell in order to protect the cells. Already just actually giving caution to the cells, you are going to be attacked like that. So these are all chemical alarm signals. Chemical alarm signals, for example, histamine, serotonin. So these are all cytokine barriers. Some chemicals released by the cells acting as intercellular messenger molecules. Transferring the message, giving caution to the adjacent cells, you are going to be attacked, be cautious, like that. So what is the best example for innate immunity? So we have diseases caused by microorganisms, either by bacteria, fungus, etc. But we cannot develop the diseases, those diseases attacking the plants. So the best example, the plant diseases normally do not attack animals because we have the natural immunity. For example, citrus canker, a bacterial disease attacking what is called the citrus plants. And now that bacterium will not attack us because we have the resistant power against that citric acid bacteria, the one which causes the citrus canker disease. Now the second one, acquired. So it is called acquired immunity because it is being developed only after birth, the one which is acquired after birth, hence called as acquired immunity. It is also called as adaptive immunity because it provides adaptation to us against the various disorders and diseases caused by the microorganisms. It is called specific immunity because it can recognize specific microorganisms and also eliminate that microorganism selectively. So recognition and then elimination. This is also called selective recognition. So they can just actually, for example, one immunity power which normally eliminates the tuberculosis bacterium will not eliminate, that is normally the one which causes smallpox, namely the smallpox virus. This is called specificity. Okay, they can recognize or able to distinguish differences among various foreign molecules. They cannot attack the same one. They can attack only one type. They cannot attack different types of microorganisms. That is called specificity. Now, this is the resistance what I mentioned normally developed in an individual after birth. That is why it's called as acquired. And it is normally more specific. What I mentioned, specificity, always actually able to distinguish differences among various foreign molecules, either bacterium or virus or fungus or protozoan, like that. And normally, this type of immunity develops following a natural infection. For example, a person develops this immunity after recovery from smallpox disease. So after recovery from a particular disease, either from smallpox or chickenpox or measles, etc., the person develops immunity. Or by means of artificial inoculation, the meaning for the word vaccination, we are giving vaccine to smallpox or polio or for example the measles, mumps, etc. So that method is called artificial inoculation. That is also called immunization or vaccination. So immunity power that is developed in an individual after recovery from the disease, that is after natural infection, or by means of artificial inoculation, that is nothing but immunization and vaccination, that is called what is known as acquired immunity. And normally this immunity is mediated by the lymphocytes. We have two different types of lymphocytes, what is seen already in histology, the B lymphocytes and T lymphocytes, and both are taking part normally in that type of immunity. Lymphocytes are mainly concerned with actually this type of immunity by producing antibodies or directly attacking them. So we have both cell mediated immunity and also antibody mediated immunity coming under this category. Cell mediated means directly the lymphocytes are attacking. Antibody mediated, some lymphocytes produce antibodies, for example B lymphocytes. And so that normally we develop immunity. So either with the help of cells or by means of antibodies, they will help us to resist against the disease. That is why here I mentioned it is mediated by lymphocytes of both B and T cells. And another property it can recognize actually, it can recognize, or it's capable of recognizing and selectively eliminating the microorganisms. That's why I mentioned an immunity which eliminates tuberculosis will not eliminate smallpox. An immunity will eliminate rabies, will not eliminate what is called the smallpox like that. So it can recognize and selectively eliminating the microorganisms. Not all the microorganisms being attacked by the same type of immunity. And as a general rule, you know that this active immunity is found only in the case of vertebrates, not in the case of invertebrates. It's found only in the case of vertebrates. But what about the development of this immunity? It requires several days to be activated. Even, for example, after recovery from smallpox, you can get actually the resistant power against smallpox. You will not get smallpox once again in your lifetime, but it takes several days to be activated following the failure of non-specific immunity or innate immunity. So normally it is operating only when the non-specific immunity, namely the natural immunity, is failed in doing so, eliminating the microorganisms. In such cases only the specific defense mechanism being activated, but it takes several days to be activated following the failure of what is called the non-specific defense mechanisms. Now actually it exhibits four important characteristics. What are the four important characteristics of that is the specific immunity? Number one, memory. So we are giving immunization or vaccination or artificial inoculation that is purely based on the memory of the immune system. What do you mean by memory? Suppose an immune system recognizes the microorganism that enters into the body. It encounters with that microorganism and eliminates the invader. It can retain the memory of that first encounter. For that we have the cells, what we have the lymphocytes. One type of T lymphocytes we have the memory cells. Such memory cells can retain the encounter of that first encounter, we can say, the first encounter of the microorganism. For example, you are infected with the smallpox. That is what is called the first encounter. That is the first time that smallpox virus enters your body. So the immune system recognizes that smallpox and eliminates that smallpox after several days of infection. And following that one, just we have developed a memory in the cells. So when I am getting what is called the second encounter with the same microorganism, namely the smallpox virus, now the immune system recognizes already the encounter there, already just knew the microorganism. That is why it fight with the microorganisms with a great speed and intensity and velocity when compared to the first encounter, so that we cannot develop smallpox once again. This is because of the memory. Even the artificial inoculation, what we call the vaccination, that also depends on the fact of the memory of the immune system. It can retain the memory of the first encounter, so that it cannot allow the spread of the disease once again of the same type in the body as it has a memory power. Then discrimination between self and non-self. Discrimination between self and non-self. The word self refers to the host body in which the immune system is there. The host body is called as a self. The non-self means the foreign agents, maybe a bacteria or a virus or a protozoa or a fungus. That is called as non-self. So the immune system knows who belongs to us, who will not belong to our family, like that. So it can recognize, able to differentiate the self molecules and self cells of its the host body. At the same time, it can also able to just understand the person who has come inside the body is nothing but a foreign molecule, so that it can eliminate it. That is the capacity of the immune system, able to differentiate its own molecules, the self, nothing but the host body, and also able to recognize the foreign molecules in the form of microorganisms or their products. Then specificity, I mentioned earlier. So it can be able to actually distinguish differences among various foreign molecules, whether it is a tuberculosis bacterium, or it is a smallpox virus, or it is a cholera bacterium, like that. It can able to recognize, or it can able to distinguish differences among various types of microorganisms. Then diversity. So it can recognize a vast range of microorganisms. So millions of microorganisms found in this world causing diseases. And as we have the power of the immune power, as we have the power of immune system, and they can have the ability of just actually recognizing a vast range of microorganisms, not one or two. That is why we can able to withstand our body against various disorders or the diseases caused by millions of microorganisms in this world. So these four properties are very important for the immune system, particularly the acquired immunity. Now let's take what are the types of acquired immunity. So we have seen the two major classes, natural or innate, non-specific. Then acquired, specific or adaptive. Now let's pass on to the second just classification, that is proceeding towards the acquired immunity. So it is being once again classified into two types. One is active and the other is passive. Regarding the duration, the one which is lasting forever after recovery from the disease or by means of immunization is the active immunity. The one which is present in our body for a long time. It is of longer duration. So it is normally initiated after recovery from infection or by means of immunization. Then what do you mean by passive immunity? It is not lasting forever. So it is not actually some products, what is called the preformed antibodies. Already prepared antibodies in some other organisms have been transferred to non-immunized organism to generate immunity. So it is only short in duration, that is called as passive. Because active immunity, the person concerned have produced the antibodies so that it is lasting forever. But in the case of passive, it is being produced by somebody and being transferred to the non-immunized individual in order to give him protection. That is called passive. So let's take what you mean by active acquired immunity. Now, it is a resistant power developed by the individual by two ways. Either by recovery from natural infection, that is while you are exposed to the microorganisms, that is by means of pathogen. It is a type of immunity developed in an individual after recovery from an infection caused by pathogen. This is what is called a natural method, because you are recovering from the disease at the same time just we are getting immunity power. But in some cases we are imparting immunity. We are introducing the immunity power or inducting the immunity power in the individual by means of introducing something from others' body, the one which is obtained from others' body. That what we can say antigenic stimulus, maybe in the form of vaccine. So that immunity that is developed in the body as a result of antigenic stimulus. So altogether called as active acquired immunity. Simply we can say active acquired immunity is developed either by vaccination, that is called artificial method, by means of antigenic stimulus, by introducing the antigen, the one responsible for causing the disease, or by means of natural recovery from an infection. So these two types of actually development of immunity together called as active acquired immunity. The one which is acquired after birth, the one which is lasting forever, but developed because of infection by pathogen or by means of antigenic stimulus, by means of immunization or inoculation of vaccine. Now let's take what you mean by artificial active acquired immunity. So there are two types. So active acquired immunity may be developed artificially or may be developed naturally. Now let's take the first one, natural active acquired immunity. The acquired immunity developed after birth. Active immunity, the one which is developed after recovery from infection or from antigenic stimulus, lasting forever. So if it is developed naturally following an infection after recovery from the disease, for example, a person who has developed immunity after recovery from the diseases like measles, mumps, smallpox, chickenpox, that is all natural active immunity because it is lasting forever till your death. A person who has recovered from smallpox can have the immunity power against the smallpox until he dies. So, the immunity developed by the host in response to natural infection that is caused by pathogen. Say an example of tuberculosis or smallpox virus, etc. So, from which normally a person. So, I mentioned already the lifetime immunity power developed in an individual after recovery from a number of diseases, for example, smallpox, measles, mumps, etc. So this is what's called the lifetime immunity, lasting forever, acquired after birth. So that is why it's called as natural active immunity because you have developed the immunity by natural method following infection. Then let's have the artificial active immunity. So this is again an active immunity lasting forever but acquired after birth, but by artificial means. How? By immunization or by inoculation of vaccine. So the immunity acquired by the host in response to artificial inoculation of antigen. Here the antigen is the word referring to nothing but the microorganism or its products. So we are inoculating means injecting. The word inoculation refers to injection. So we are injecting the microorganisms in a weak form or a modified form, and that is being considered as an antigen. So that is why using the word antigen, here the antigen, the word referring to nothing but the microorganisms or the products. So the immunity power that is normally acquired by an organism after birth, just following artificial inoculation of antigen, which is nothing but a microorganism. Okay. For example, we are doing vaccination for different diseases, mainly for polio, pulse polio. Then DPT, triple antigen, polio for polio, then DPT triple antigen for diphtheria, pertussis and tuberculosis, and also another vaccine, MMR vaccine for 3 diseases, measles, mumps and rubella. That is nothing but actually a German measles. So these are all the methods what we are actually imparting the artificial, just what is called active immunity by means of vaccination or inoculation. If a person develops immunity, then it is called artificial active immunity, but it is lasting forever. It is also based on the fact that the immune system has the memory power. Now, the passive immunity. Here normally it is the resistance developed by an organism. How? Actually, transfer of some ready-made antibodies. So in the case of active immunity, we the person, the affected person, the person who is in question affected can develop antibodies on his own or on her own. That is why it is lasting forever. But here we are preparing something in other organisms, we are transferring that one into the body of a non-immune individual to impart immunity. So, and those antibodies which are prepared from other organisms are simply called as pre-formed antibodies or ready-made antibodies. So, the ready-made antibodies are nothing but pre-formed antibodies. Pre-formed antibodies made by some other organisms, and from that organism we have to extract the antibodies and introduce into the body of a non-immune individual. As it is prepared by some organism, some other organism, and though it is normally imparting immunity, it is not lasting forever because it is being introduced from somebody. The strength is very less, so it is of shorter duration. So such an immunity is called passive. So the resistant power that is developed by the transfer of ready-made antibodies or preformed antibodies which are normally developed in other organisms. For example, we are developing a number of what is called the vaccines or serum, anti-tetanus serum, for example ATS. So like that we are obtaining this one from other animal body or simply from mother to child. The antibodies are transferred. So either from mother to child or from some other animal. we are transferring the antibodies, and these antibodies are called ready-made antibodies or preformed antibodies. They are responsible for imparting immunity in a non-immune individual. Now what are the types of, as in the case of active immunity, here also we have natural passive acquired immunity as well as artificial passive acquired immunity. So what do you mean by natural passive acquired immunity? So in this case actually the preformed antibodies from mother to child, transferred from mother to child. See that one. The preformed antibodies from mother to child actually transferred so that the child develops immunity power. So the immunity normally transferred from mother to child. This is normally already the antibodies are formed in the mother's body. The mother's blood normally transfer the antibodies to the fetal blood so that the fetus, the developed embryo, develops the power of immunity. Such an immunity, but not lasting forever, that's why it's called as passive, and also occur only just after birth or during development. As normally it is caused, natural method is called natural passive acquired immunity. See, the immunity transfer from mother to child by transfer of, I mentioned already, the ready-made antibodies, what are called preformed antibodies. The best example, you know that one, during development, the preformed antibodies are child. So the preformed antibodies are transferred to the child from mother through the breast milk. The first formed breast milk during normally the initial days of lactation means the formation of milk. So during the initial days of lactation, an yellowish fluid is secreted, that is a milk, but the milk is called the colostrum. The first formed milk, which is normally yellowish in color, secreted during the initial days of lactation, is called colostrum. That is why mother's milk, the breast milk, is the best milk for the child. The reason for that one, this colostrum contains abundant number of antibodies, particularly IgA antibodies. So it contains large number of antibodies. That is why doctors are always advising, it is always better to feed the young one with breast milk. This is because of imparting immunity as it contains large amount of antibodies. So the first formed milk is called colostrum. It is normally not white in color, yellow in color. As it contains abundant antibodies, it may be given to the child to develop the immunity power. So that is why if a mother is feeding the young one for nearly 6 months, that young one has more resistant power than anybody else. And likewise also the preformed antibodies not only transferred from mother's milk to the child during feeding, even during development from mother's body, antibodies are transferred to the developing fetus through placenta. It is also an example for natural, that is passive acquired immunity. But it is not lasting forever. It is only just protecting the child for certain ages. So the transfer of antibodies from mother's milk to the infant or from mother's blood to the developing fetus through placenta are examples for natural passive acquired immunity. Now the artificial one. Here actually the antibodies are prepared, what we call this one, the preformed antibodies, in some other organisms, body. For example, the serum of such animal develop antibodies by introducing the antigen into them, and from that animal we are extracting the antibodies, we are introducing or inoculating such antibodies into the non-immune individual body. Then it is called artificial passive acquired immunity. See, the transfer of antibodies, the one which is normally actually prepared or produced by immunized donor. The immunized donor may be a man or animal, for example horse or rabbit, to non-immunized individual, the one which is not having a resistant power. So we are making the antibodies to be prepared by some other animal by the inoculation of the antigen, the one which causes the disease. And after that we are extracting the antibody from the animal and introducing the antibody to non-immunized individual for short duration of what is called immunity. As it is normally obtained from some other organisms prepared artificially, it is called artificial passive immunity. One best example, for example, we are giving injection of ATS. This is simply called anti-tetanus serum against tetanus bacteria. So this one contains abundant antibodies for what? For working against the tetanus bacteria. So we are giving 8 years. This is what is for passive. We also have TT, tetanus toxoid. So this TT is for active acquired immunity, whereas 8 years is meant for passive acquired immunity, artificial passive acquired immunity. This is for artificial active acquired immunity. Both are used mainly against the tetanus bacteria. So the anti-tetanus serum is normally obtained from the serum of horse, which contains abundant antibodies. That is what is called the immune individual. Being transferred to man, he is called non-immune individual. That is called artificial passive active immunity. The best example I mentioned already, is not a permanent one. Even when we are impacting for immunity against cholera, only during festive seasons, we are just inoculating cholera vaccine. It is also of shorter duration. It is also another example for artificial passive acquired immunity. Okay. So these are all some of the types of immunity power what we have developed to resist against the different types of disorders. Now immunization. This is nothing but inoculation of vaccine. So the inoculation of vaccines are administering vaccines. What for? To prevent diseases. It's called immunization program or simply immunization. We are just administering vaccine means actually we are introducing the vaccine. I will come to what you mean by vaccine. This is what is called immunization or simply vaccination. I mentioned already the immunization program or immunization method is based on the property of the memory of the immune system. Once we are injecting the vaccine or inoculating the vaccine, what will happen? The body develops immune power. For example, we are injecting the smallpox and inoculating the smallpox vaccine in the body of a person. He developed resistant power against smallpox. How? So now the cells retain the memory power of that antigenic stimulus in the form of vaccine. So during actual infection with the smallpox virus, now because of the memory in the cells, they can attack the smallpox virus, not allowing them to be present or to be multiplied inside the body. This is what we have the memory. Because of the memory of the immune system, they can attack. So the artificial active inoculation is based on the property of the memory of the immune system. So any immunization normally develops what is called artificial active acquired immunity, but lasting forever. Not passive, it is active but acquired, but artificial method. Now what is vaccine? So vaccine is nothing but a preparation of antigenic proteins. Suppose for example the smallpox virus, the one which causes smallpox. The smallpox virus has been taken. It is modified in such a way that it cannot produce disease but it can impart immunity. So without reducing their capacity, without reducing their capacity to impart immunity, but reducing the virulence power. Virulence means actually the harmful nature of that microorganism. So they are modifying the virulent nature of the microorganism so that it cannot cause the disease but can impart immunity by stimulating the immune system to form antibodies. So vaccine is nothing but preparation of antigenic proteins that is obtained from the microorganisms, maybe the pathogen, or it may be an inactivated, that is a live one, but its function has been modified in such a way that it cannot stimulate the disease but it can stimulate the antibody production, thereby imparting immunity. So a vaccine normally contains antigenic proteins or a weakened or inactivated pathogen. For example, smallpox vaccine contains actually the vaccinia virus. That virus normally in a modified form. So such a modified or weakened microorganism is called attenuated. Attenuated vaccine. Weakened. Its efficiency as a virulent is weakened, but it can have the efficiency of just imparting immunity. So we have a number of vaccines available nowadays. You know that one OPV, oral polio vaccine, normally called as a Sabin vaccine. or we are giving what is called inactivated polio vaccine. So the oral polio is now actually prevalent in our country. We are imparting immunity against polio by oral polio drops. It's otherwise called a SAVI vaccine because it was first proposed by SAM. We also have another vaccine, inactivated polio vaccine, also called SALT vaccine for polio. We have seen already the MMR vaccine for the three diseases, measles, mumps and rubella. Then BCG, the first vaccine to be given to a child after 15 days. After the name of two persons, colmeticronine, obtained from this bacillus. This is called BCG vaccine, Bacillus colmeticronine, what for? Against tuberculosis. Then DPT, it is called triple antigen because it is for against three diseases, diphtheria, pertussis and tetanus. Then DT, it is called dual antigen because it contains only two. One for against diphtheria, another one for tetanus. That's what's called dual antigen. Then TT, tetanus toxin. So what do you mean by toxin? A modified form of toxin. Suppose for example the tetanus bacterium produces one enterotoxin, it produces an exotoxin. It produces an exotoxin outside its body. The toxin released by the tetanus bacterium is collected and modified in such a way that it can be used against the tetanus bacterium. So its own toxin is modified so that it can impart immunity against tetanus bacterium. That modified toxin is called toxoid. Now immunization schedule. So we have seen every just this week, this Sunday is for polio, this Sunday is for BCG, etc. That is for immunization schedule. So this indicates normally the stages at different stages of development, starting from birth up to the adult stage. The stages at which normally the vaccinations and inoculation have to be given to the child to safeguard what for against different diseases. So that's why it's called immunization schedule. We cannot give all together at the same time. We are giving BCG vaccine at the end of 2 weeks after birth, then we won't give BCG vaccine after that. But we are giving this oral polio vaccine, first dose, second dose, booster dose, like that. So that schedule is called immunization schedule. So it is a stage at which, or we have different stages of development, at which normally the vaccination and inoculations have to be given to that is the individual, what for? To safeguard the individual against the different kinds of diseases. This is what is called immunization schedule. We cannot give oral polio vaccine, BCG vaccine, DPT, TT, etc. together all of a sudden. Each one to be given only at a particular time schedule during the development of individual. That's called immunization schedule. You know, World Health Organization has developed the global immunization program. 1974 March, what for? To eradicate 6 diseases, the most common diseases in the case of children causing the death of individuals taking their lives. So, the World Health Organization started the global immunization program, that is the vaccination program or inoculation program against 6 diseases. So, we have for example DPT and MPT. So, 6 diseases are diphtheria, that is we have pertussis, whooping cough, and tetanus. Then measles, then we have the polio and tuberculosis. So diphtheria, pertussis, tetanus, then measles, polio and tuberculosis. So they have started the program to impart this program to just develop immunity and also immunity against these diseases and also to eradicate these diseases. That was started in 1974. So as a result of this one, now the deaths because of these 6 diseases have been decreased dramatically because of what is called the medicinal vaccination. So these are all the different types of immunity power. Though we have actually immune power in the body, sometimes we are losing the immune power because the pathogen is having more power than us. Sometimes what will happen, our own immune system attacks us instead of microorganisms are attacking us. For example, when microorganism enters into the body, immediately our immune system develops the immune power. That immune power, instead of attacking the microorganism that enter into the body, it attacks our own cells, the cell molecules. Then it is called autoimmune disease. For example, rheumatic arthritis, one disease. multiple sclerosis, insulin-dependent diabetes, myasthenia gravis. So many diseases have been developed in our body because our own immune system attacking us, attacking our own cells instead of attacking the invader that entered into the body. And one such disorder we have developed frequently, you know that one, the most disorder, the pandemic one, worldwide disorder, AIDS, acquired immunodeficiency syndrome. The word syndrome refers to a number of recognizable signs and symptoms. One, a disease which causes a number of recognizable signs and symptoms, then is called a syndrome. You know, you are familiar with this word AIDS, acquired immunodeficiency syndrome. So it is being acquired after birth. That's why it's called acquired. Immunodeficiency because the virus attacks our immune system, making the immune system non-functional. So the immune system is deficient, not working. Syndrome, a number of symptoms. This is why it's called acquired immunodeficiency syndrome. Now, what is the nature of this disease? You know that what it is a viral disease caused by HIV virus. So it is a lethal, harmful, transmissible, easily transmissible, and sexually transmitted disease, mainly. Sexually, though we have different means of transmission, the prime method of transmission is by sexual method. That's why it's called sexually transmitted disease, one which is occurred during the lifetime. That is why we can say that actually this acquired immunodeficiency syndrome is not a congenital disease. The word congenital means it is being transmitted from the parents through genetical means, or the one which is being normally transmitted by means of microorganisms. So it is not congenital means it is not being transmitted from parents to the young ones through genetical means. It is being transmitted by means of what is called either sexual contact or through transmission of actually the infected blood, etc. That's why it is not a congenital disease. So normally the disorder was first reported in 1981 while studied by the Center for Disease Control in US. So that center was responsible for the identification of this disease. But in 1983, a person, a French scientist by name Dr. Montagnier, he was the first person isolated the causative virus for the AIDS. But in 1984, it was confirmed by another scientist of NIH, Robert Gallo, National Institute of Health in USC. He was the first person to isolate the virus from the AIDS patient body. He called that one HTLV3, human T lymphocyte virus 3, human T lymphocyte virus 3. But later, the taxonomy on virus, the Committee on Taxonomy of Viruses, have given one common name to be accepted by all, namely HIV, human immunodeficiency virus. So the Committee on Taxonomy of Viruses has given the name HIV to just avoid the confusion, as so many names have been given to this virus. And finally now the standing word HIV is meant for, that is the causative organism, human immunodeficiency virus. Now let's see the structure of HIV. Now if we are taking actually the structure of HIV, let's show the picture. Now it contains a central icosahedral capsid. What I'm just encircling is central icosahedral capsid. Icosahedral having 20 faces, 20 sides. Central icosahedral capsid. So normally it is an enveloped virus. It is an enveloped virus, more or less spherical in shape, having the dimension of 100 to 140 nanometer, the diameter. So normally in virus we have only a protein coat which encloses the nucleic acid. That is called nucleic capsid together. A virus particle, what we call this one virion, is nothing but encapsulated one with what is called a capsid coat enclosing the RNA in most cases. We also have DNA, know that in the case of bacteriophages. But in the case of this virus, it has an extra envelope. So you have, this is the envelope, a protein envelope. This is a capsid coat and another layer, a lipoprotein envelope. So this is purely the capsid is protein, whereas this envelope surrounding this one is a lipoprotein envelope having both protein as well as lipid. So if you take the structure of virus in simple means, it has a central icosahedral capsid. That capsid encloses or contains two single-stranded RNA, the one which is in wavy, the red color one, the filamentous one, two just actually single-stranded RNA. That is why such viruses are called diploid viruses. Normally in the cells or in the viruses we have only one strand of RNA. This is the common character. But here you see that one there are two. Only you know that one DNA alone found in double helix or double strands. But in this case there are two identical separate strands of RNA being found in the case of such viruses. That is why the retroviruses, normally the HIV viruses, are called diploid viruses. So normally the AIDS virus belongs to the family Rhabdoviridae family of retrovirus group. Not Rhabdoviridae, I made a mistake. That is actually Lentiviridae subfamily group, and they are all called retroviruses. The AIDS viruses are called retroviruses because they have one enzyme in them what are called reverse transcriptase. They have reverse transcriptase. So we have a central capsid, icosahedral capsid, which encloses what is called the genetic material or the genome. The genome is in the form of actually two identical strands of RNA. That's why they are called single-stranded RNA. Now this capsid has been surrounded by the protein coat. You can see there is actually the filamental structure. This one represents the protein coat. Normally the protein coat has an attachment of glycoproteins. So it has an attachment of many spicules of glycoprotein. What you have this structure is nothing but glycoprotein, simply called as GP. This is called GP. You see that one, GP 120, GP 41, like that. So, and spicules of glycoproteins are actually found attached to the protein envelope. The spicules are actually found, sticks out both inside and outside the protein coat. The part of what is called the spicule, which is normally present on the just outer side, is called GP 120. This part is the GP 120, glycoprotein 120. Number 120 refers to what is called the sedimentation coefficient. And whereas actually the inner position to which what is called the norm-like GP 120 is attached is called GP 41, glycoprotein 41. So this is nothing but spicules which is stick out both inside and outside the protein envelope. The part outside the protein coat, the projecting one, is called GP 120. The part inside is called GP 40. And these molecules are actually attached to the cell surface receptors during infection. They form a complex with the cell surface receptors during infection. Now, attached to the RNA molecule, one specific enzyme is found. That is why it is called as retrovirus. So it contains reverse transcriptase enzyme attached to the RNA molecule. So this is a peculiar condition because you know that one, it is called reverse transcription. Normally you will be studying in higher classes. DNA directs the synthesis of RNA. DNA directs the synthesis of RNA during actually the multiplication of the virus. So in normal conditions, for example, in our cell we have the DNA. This DNA directs the synthesis of RNA. This process is called transcription. This process is called transcription, copying of RNA on DNA. But sometimes what will happen, the RNA directs the synthesis of DNA. That is, it occurs in the opposite direction. That is called reverse transcription. That process is called reverse transcription. So what will happen when this virus enters into a body? It enters into either macrophage or helper T cells, where its RNA undergoes replication to form DNA. So that process of conversion of this viral RNA into DNA is called reverse transcription, brought about by the enzyme reverse transcriptase. Once the DNA is formed, it integrates with the host cell, for example, helper T cells, or we can have the macrophages, and replicates along with the host cell DNA. This DNA, the viral DNA, also directs the synthesis of the viral RNA. In this manner, only the virus is multiplied. As this enzyme is peculiarly responsible for the reverse transcription process, the viruses are called retroviruses. See that one, the reverse transcriptase enzyme. So in addition to this, actually the reverse transcriptase, we have actually a number of enzymes, for example protease enzymes, integrase enzymes, and we have, for example, the matrix, then the capsid coat. This is what we have, the capsid. This one is a capsid and this one is a matrix. And also GAG protein, just general antigenic proteins, we not worry about. Now this is the RNA. And what we have mentioned, this DP120 and then 41 examples for enveloped proteins. Now the stem is called transmembrane protein, transmembrane envelope protein, and this one is called, actually the knob is called surface membrane actually envelope protein, surface membrane envelope protein. So we have different types. There is a simple organization what is given the complicated structure, but we have more structures. We are getting more information when we are coming to higher classes. Okay, I proceed to simply the structure, a capsid in the center with the genome, then protein code, and then we have the GP120 and GP41 of the glycoprotein structures. The one, some spicules stick out outside and inside, and they are responsible for attachment with the receptors, the cell surface receptors during infection. Elevate. So it is a single glycosylated capsid containing single-stranded RNA as a genetic material surrounded by a protein envelope. The protein envelope has an attachment of several spicules of glycoprotein, what are given GP. The GP sticks out on both sides of its protein coat on either side. The outer position of GP is called GP120, which is attached to the GP41, the one which is situated on the inner side of the protein coat. These proteins I mentioned earlier bind to the host cell surface receptors. For example, the T lymphocytes are macrophages during infection. Now the central protein core contains single-stranded RNA. Normally one strand, but there are two strands of actually genome and few molecules of reverse transcriptase enzyme, the one responsible for doing the process of reverse transcription for the replication of the virus. So a single-strand viral RNA is converted into double-stranded DNA by the reverse transcriptase, what I mentioned. That is why the process is called reverse transcription. We are getting more information coming up. We are not able to follow this one. So this is the structure. Now pathogenesis. The word pathogenesis refers to how far actually the disease being developed. The process of development of disease is called pathogenesis. Normally the virus, the HIV virus attacks two types of cells. One macrophages, another one T helper cells. T helper cells. Under the T helper cells there is one type what is called CD4. CD4 T helper cells. Cluster differentiation molecules. Simply CD, the expansion for that one. So it attacks simply two different types of cells. First, normally the virus enters into the macrophage, a type of WBC, and using this macrophage as a reservoir. A reservoir is a place where normally a particular microorganism or a particular pathogen multiplies. The place of multiplication of microorganisms or pathogen is called what is known as macrophages. Now, the first target cell for the virus is the macrophage. So inside the macrophage, what will happen? The RNA genome, what I mentioned. Now this is the RNA virus, the RNA of the virus. It replicates to produce what is called the DNA. Now the DNA directs the synthesis of virus particles. So in this manner, inside the macrophage, the virus particles are increasing in number. That is why the macrophage is considered as a HIV factory. HIV factory. So once actually the viral RNA gets converted into DNA, it integrates with what is called the cellular DNA, for example T lymphocytes and macrophages, and multiplies along with the cellular DNA. At the same time, it directs the synthesis of virus particles, what is called the viral genome RNA, and that may be packaged to form the viral particles. So that is why as the macrophage is acting as a reservoir for the production of enormous number of virus particles, it is called as HIV factory. Then another type of cell which is being attacked is nothing but the helper T lymphocyte, simply called as TH. Inside this cell, normally the virus particle enters. Now the RNA of the virus particle directs synthesis of viral DNA. The DNA integrates with the cell DNA of the T lymphocytes, and that DNA also directs the synthesis of viral RNA. So the viral RNA being packaged to form the virus particles. So in this manner, a large number of virus particles are produced. Once large number of virus particles are produced inside the T lymphocytes, now what will happen? The lysis or the destruction or the rupture of the T lymphocytes occur, so the virus particles are released. And they approach the fresh lymphocytes, enter into the fresh lymphocytes. The same process has been repeated, producing more and more number of virus particles. As a result, what will happen? More number of T lymphocytes have been destroyed. There is a depletion in the number of T lymphocytes because the T lymphocytes are responsible mainly for stimulating the B lymphocytes to produce antibodies to impart immunity. As the number of T lymphocytes has been decreased, now we are losing the immune power. We have the what is called a depression, so that we cannot tolerate any other types of disease. Simply we are attacked by the AIDS virus and also other diseases. The person is developing so many number of complications. Ultimately, it leads to the death of the individual finally. So we will see furthermore about these virus and their effects, how far we have to protect, how far we are protecting us from this one, what are the preventive measures, the controlling measures, etc. The next class, as one of time, I am concluding my part, we proceed the next one.